Hello and welcome to this video where we will take a look at the computational thinking concept area. You'll note that I am back on page 18 of the PDF on the New York State Computer Science and Digital Fluency Learning Standards PDF. And you'll note that the computational thinking is broken down into 4 sub-concept areas. Please also note that this is the largest of the standards. You'll note that there's 10 standards completely within this concept area. It is broken down into 4 sub-concept areas: modeling and simulation, data analysis and visualization, abstraction and decomposition, and then algorithms and programming, which are the largest area of the standards. Now what we're going to do is scroll down to the page that starts the standards, which is page 24 of your PDF. You'll note that modeling and simulation is the first of the sub-concept areas. Again, I'm only going to read the grades 7, 8, but I do recommend that you look below and above to see where the students should be coming up with and where they need to go when they are done with 8th grade and move on to 9th. But the first standard within modeling and simulation states that to compare the results of alternative models or simulations to determine and evaluate how the input data and assumptions change based on the results. The focus is understanding that models or simulations are limited by the data that they use rather than understanding specifically how they use that data. So you might have the students change different things within a math problem and see how that changes the output. And then they can try to make predictions based on what the simulation seems to be doing. As we move into data analysis and visualization, the first standard says collect and use digital data in a computational artifact. Here we're talking about the emphasis is on designing and following collection protocols. Data sources include but are not limited to sensors, surveys, and polls. So anything you typically do in your classroom where you have your students collecting data can really fit this standard. As we continue on with data analysis and visualization, here we're going to refine and visualize a data set in order to persuade an audience. So here's a great chance to do an interdisciplinary activity where they might be collecting information using math and over something in social studies and then persuading someone using ELA. Here we're refining includes but is not limited to identifying relevant subsets of a data set, deleting unneeded data, and sorting and organizing data to highlight trends. As we move into abstraction and decomposition, we're talking about writing a program using functions or procedures whose names or other documentation convey their purpose within a larger task. Here, the focus is on identifying where there is a potential to use a function or procedure to create reusable computation. So really, we're taking a look at those things that we might write more than once and how we can organize that information. Continuing on with abstraction decomposition, you're going to identify multiple similar concrete computations in a program, then create a function to generalize over them using parameters to accommodate their differences. Again, the focus here is identifying similar expressions or sequences in codes and abstracting them into functions that generalize over similarities. So this again could be something you're doing in math or in science where you realize there's certain functions you do fairly often and you can generalize and use them more than once. And then we get into our algorithms and programming. And again, this is the largest of the sub-concept areas. So let's take a look at these standards. We're up to CT6 here. Here we're defining, comparing, and refining algorithms for a specific task or within a program. These can be represented in a range of formats, including flowcharts, pseudocode, or written steps. Planning the output of a program, such as with a storyboard or wireframe, is not sufficient on its own. So here we can certainly use a storyboard, but we want to think beyond that and really think about how we can refine. So this is really where the step becomes a lot larger in that we want to really be thinking of this through that computer science lens. Continuing on with algorithms and programming with CT7, we're designing or remixing a program that uses a variable to maintain the current value of a key piece of information. The focus is understanding that variables can be used to track the value of a concept in a program as it changes over time. The next one in CT8 is develop or remix a program that effectively combines one or more control structures for creative expression or to solve a problem. The focus is on having students combine control structures such as conditionals and loops in such a way that they work together to achieve an outcome that cannot be achieved using only one of them. And our last two really are really talk about using computers to think about code and think about our process and our designing. Now, number 9 is read and interpret code to predict the outcome of various programs that involve conditionals or repetition for the purposes of debugging. Programs can be debugged in numerous ways, including tracing and trying varying inputs. Perseverance is important in finding errors, so we're really working on those soft skills in this one. And then as we move on to CT10, document the iterative design process of developing a computational artifact that incorporates user feedback and preferences. At this level, the emphasis is on using the iterative, so really doing it more than once, really thinking about the process or the engineering process here, to create a solution or prototype within the end user in mind, or with the end user in mind, and then to document the steps taken by the student to gather and incorporate information about the user into a computational artifact. So really, we're really getting into some higher order thinking as we get into these standards. So again, if these are brand new to you, please take some time and review and make them a little bit more familiar, read through them, and then as we get into um, the next module and we talk about the examples, these hopefully will be brought to light even more for you.